Hey everyone, it's Ben from Board to Bits, and I'm recording this video today because I came across this visual effect in my game development efforts, and I thought it looked really cool, and I wanted to share it with you guys. So, first off, just to put a little disclaimer out there, I'm not that well versed in shaders and image effects, so there's going to be a little bit more of me saying this is how you write something just because that's how you tend to do it than usual. I usually try to explain things a little bit better, and I'll still certainly do that as we're going along, but there may be a little bit more hand-waving than usual. Also, I have to give a shout out to the blog unionassets.com. I'll put a link to the article that I first found in the description below, because that's really where I kind of got the foundation for what I'm doing with this black hole effect that I'm creating. I've certainly put on some of my own spin to it, some of my own optimizations, but that was definitely where if you look at their article, where I kind of got the basis for it. So I owe a great deal of credit to them for getting this video off the ground. So I've always been kind of fascinated by black holes, particularly their visual impact on things, because they do really kind of weird visual stuff. The first one, which is a little bit more easy to wrap your head around, is that if something were to hit the surface of a black hole, or more accurately the event horizon, that light never escapes from that black hole. So there's never, a black hole is just always kind of this void of visual information. It's just this circle of darkness because nothing is actually getting out to you. The other thing though that's really interesting is any light that goes near that surface or event horizon gets bent by the sheer gravity of the black hole, and so what ends up happening is you either get light that you wouldn't normally see that suddenly gets bent back toward you, or light that you would have seen but it's suddenly being bent and coming from another angle or coming from a different direction, such that it creates these really weird warping effects, which are called gravitational lensing, and that's really what we're going to be kind of simulating with this image effect. So this video is going to go through three parts. First, we're going to quickly set up the scene. We're just going to need a couple game objects for that. Then we are going to actually create our image effect class, which we're going to attach to our camera. And then finally, we're going to create the actual shader script, which will be used by that image effect. So let's dive in. Part 1, scene setup. So to start, we're going to create a new project in Unity. We're going to set it to 3D. I'm going to name it Black Hole Effect. And we create a project. With our project loaded, we technically only need two things in our scene. We need a main camera, which we have already set up here, and we need to create an empty object, which I'm going to call Black Hole Positioner. And really all this is this object's transform is going to be what informs where the center of the black hole is. Now this is all we technically need for this project to work, but I'm going to add a couple more things just so that we can really kind of get the visual experience of the effect. First thing I'm going to do is I'm going to add a new skybox to this scene. This one is okay and you get a little bit of the warping, but it's really kind of just a simple gradient, so I feel like something with a little bit more detail would be better. I'm going to right click in the assets folder, and I'm going to import a custom package. This one is on my desktop. I will make this available in the description below. You can download it and access it from wherever you need to. But all you should have to do is click on this painted space skybox package rather. Click open and it will give you the option to add this to your hierarchy. I'm going to import all of the files. And this is going to import 6 images as well as the skybox material that puts all those images together for us. With that here, we can open this up, see that those all appear here. This is the material, and these are the 6 images. Now what we can do is go up to Window, Lighting, and this is where you actually get your default skybox for the scene. And so I'm going to click in here and click this little target button and change it from the default skybox to our painted space SB. And this is just really a kind of simple space-like skybox that I made. It's not the greatest thing in the world, but it gets the job done. Feel free to use it if you want to. It's considered a freebie from watching this video. So with that in place, now when we see the black hole and the warping happen, it's really going to affect these stars and the kind of gradients and that you see within the space here. So it's going to have much more of an impact than just having that single gradient, or even worse, just a solid color, which you wouldn't see anything at all. In addition to this, I'm going to add a couple of spheres to our scene too. You could certainly add some materials to these if you wanted to make them look like planets or stars or something, but I'm just going to keep a couple of simple spheres in our scene. And those are, again, just going to kind of add just a little bit more of that visual appearance of, oh, hey, this black hole is actually doing something to the appearance of the scene. These are not required at all. They're just kind of cool to have. Scale this one down a little bit. And with that, our scene is good to go. Part 2, the image effect script. So now that we have our scene set up, we can add our image effect class to our camera. In order to do that, we're going to need to right-click in Assets and actually create this class. It's a C# script. And we're going to call this black hole effect. Now notice I'm not calling this a shader because this isn't actually the shader, rather this is the script that is then going to implement a material with that shader that we're going to create in part 3 of this video. We can open that up in MonoDevelop. I'll maximize this and zoom in a little bit here. And so we can delete the start and update. We're not going to need those for now. And in here, this image effect is really just a class like any other class you're going to create. However, in order for it to work with the camera, there's a few things that we need to make sure of. The first is that this class is going to need to be attached to a camera object in your scene. We can do that easily enough as long as we say up here, just above the class declaration, we can say require component type of camera. We'll just make sure that when we're attaching this to an object, there's a camera there. Now we can add some public settings. As well, there are going to be a few private settings that we'll get through code. So our public settings are, first off, we're going to have the shader. So we're going to say public shader, and this is where we're going to put the shader we create ultimately. Next, we're going to have a public transform. We're just going to call this black hole, and this is that empty game object that we created. We're going to put that here, and that's really just going to be so that we can reference its position in the scene. Next, we're going to have a couple floats. We're going to have a public float that I'm going to call ratio, and this is actually going to be responsible for the aspect ratio of the screen. And this is, we're actually going to figure this out procedurally when we start our game. However, if we ever want to have the black hole appear when we're in edit mode, it's nice to be able to kind of adjust that manually. That's why I'm making that a public float. And lastly, another public float called radius. And this is going to set the size of the black hole itself, the dark space in our scene, whether we want it to be 1 unit, 10 units, etc. Size of black hole in scene. Okay. For our private settings, the first thing that we're going to add in here is a reference to our camera, which we're going to get in an awake function. Secondly, we're going to have a material, and I'm calling that underscore material. This is something that we're actually going to procedurally generate right, as we start our scene. So I'm putting that underscore ahead of it just to kind of say that this isn't something that exists out like in edit mode. It doesn't exist until we are actually running the script. Will be procedurally generated. So with all of these, we can now, we're going to need to actually create that material though. And we could just do this in our awake function. However, there may be situations where we don't have a black hole in the scene. We don't need to create that material at this time, and there's no need to create that and kind of be using up space in our program. So what we can do is actually, when we make a call for the material, we can create it then if it doesn't exist already. We can do that using a property, using a getter, to say, hey, get this material, and if it doesn't exist, just make it now. So we'll say material. This is the other reason I'm using that underscore up here, because I couldn't, normally what I would do when I'm making a property is capitalize it. But in this case, because material is already a claimed name in Unity and in C#, or in Unity really, I'm just going to keep this lowercase, then keep this one with the underscore to kind of differentiate them. And then we're going to create a get call in here. And what we'll do is say if material equals null, meaning if we have not yet created a material, then material should equal a new material. And you'll see that Unity gives you a few different constructors for materials, including you can create a material out of an existing material. This one is actually obsolete, so don't worry about that one, but this is the one we're going to use, where what you do is you create a material and you simply pass in a shader. And conveniently enough, we're putting in a shader in our public settings, so we'll simply say create a new material using that shader. Lastly, there is a thing here called material.hideFlags equals, and then you can say hideFlags dot hide and don't save. This is one of those things that I'm not super familiar with, but it does seem to help and make sure that I think it basically doesn't save the material to assets. Don't quote me on that, but it's something you can add in there and it will help things run smoothly. So once that material has been created, if it needs to be, then we can simply return material. And so that's a way of kind of getting this way of accessing the material, but also making sure it's created at any given time. Next thing I'm going to do is I'm going to add a void on enable method here. So this will happen whenever the camera is activated. And we're going to just quickly make sure that we have our camera reference. So we're going to say cam get component camera. And also I'm going to, at this point, set our ratio, that aspect ratio we had, and this is going to simply be equal to 1f divided by cam.aspect. So the aspect ratio is traditionally, I believe, height over width. We're actually using a width, or as traditionally width over height, we're going to be using a height over width. So we have to invert it, and that's why we're dividing it into 1. Lastly, we can have a virtual void on disable. And this one is going to be that if, when we disable this camera at any time, if we have created a material, we're gonna, if the camera's off, we no longer need that material kicking around in memory, so we can simply say to destroy immediate material. Destroy immediate is something you should use very sparingly, if at all. This is a case where you can use it safely, so you can do that here. Lastly, as I said before, there's a few things that we need for an image effect to work, one being attached to a camera. The other is a special method that gets called, it's kind of an event, it's called onRenderImage. And it looks like this. We're going to say void onRenderImage, and it's going to have a render texture called source and a render texture called destination. And basically what this does is when this is attached to a camera, when the camera takes in the scene, takes in all the pixels and says, okay, this is the image I have of the scene, that becomes this source. And then what happens is you do whatever processing you'll do in here. Processing happens here. And then it passes out to the destination the modified image, which is what gives you these different effects, these sort of, whether you're changing the colors or, adding bloom or anything like that. This is where that magic happens, is right in here. So how we're going to do that in this case is we're going to say if the black hole is within our camera view, then what we want to do is we want to apply our shader to it. And so in order to do that, we have to do a few extra things here. We can't just simply say, apply the shader immediately, because there are going to be a lot of situations where, we might not be looking at a black hole and we don't want to be doing that because it's taking up extra time that we don't necessarily want to be wasting. So the first thing we're going to do is a quick sanity check and say if there's a shader attached to this class, like if we've actually put a shader in there, if our material exists, and actually that should be our creatable material, and if our black hole exists. If those three things all exist, then we can proceed. If not, if any of those are not there, then we need to just skip this process because we're going to run into errors now. So the first thing I'm going to create is a vector3 called WTSP. And that stands for World to Screen Point. And basically what that does is it takes any object in our scene and says, where is that appearing on the screen itself in terms of the X and Y of the pixel map of our screen. So we'll say equals cam dot world to screen point, and then we have to give it a vector3 position, and so we're going to give it the black hole's position. So that's basically just getting us the screen position of the black hole at this time. Now, actually, it's not really the best move for us to be making this vector3 every single time. Instead, what I'm going to do is I'm going to actually create a vector3 variable up here called WTSP, and then we'll simply modify that vector3 every time, every frame. Because remember, this onRender image is getting called every single frame that the camera is rendering an image, so that adds up. In addition, once we have that now, what we can check is that we want to check, is the black hole in front of the camera? Because there's this weird thing that when you get a world to screen point, it will appear, even if the object is behind the camera, it still appears within the X and Y as if it were in front of the camera. Like it doesn't, that is held by the Z information. So we want to make sure that, hey, even if this thing is directly behind me and would in theory be right in the center of my line of sight, if my line of sight extended backwards, it's behind me, I can't see it, so don't worry about it in that case. So we'll say at this point, if WTSP.Z, if the Z value is less than 0, or sorry, is greater than 0, then we can continue. Otherwise, we're going to skip out of this and skip out of the this loop or this if check and skip out of this process altogether. So in here, what we're going to do is we're actually going to create another variable up here. We're going to call this vector2 POS for position. And POS is going to equal a new vector2 equal to WTSP.x divided by the camera's pixel width. So what this is doing is basically taking the pixel position of the black hole on the x-axis and dividing it by the total width in pixels, so that we're basically normalizing. We're taking a number that's probably something like 172 pixels and turning it into something between the values of 0 and 1, which is what shaders like to work with. And then we're going to say WTSP.y divided by cam.pixel height. So now we go from this number that's probably in the hundreds on both axes to something that's between 0 and 1. The next thing we're going to do, with all this information in hand now, we can apply our shader parameters to the shader that we are using. So we'll say apply shader parameters. And there's a few things we're going to put in here. We're going to put a material.setVector, and this is going to be our position, and this is going to be our vector 2. Next, we're going to apply a material.setFloat, and this is going to be called ratio, and in there we're just going to pass our aspect ratio. Next, we'll do material.setFloat RAD for radius, and that is going to be equal to the radius that we set. And finally, material.setFloat distance, and this is going to be equal to a vector3 dot distance. So we're going to do a quick calculation here, and we're going to check the black hole's position versus our current position. Now, it is worth noting here a couple things. The first is that in the first parameter of each of these, I am putting a string, so I have in quotes. I am starting with an underscore, and I have a capital P, and then the names. And the names are position, ratio, rad, and distance. That's going to be important. It doesn't, you can technically name these whatever you want, you just have to make sure they match up with what you put in your shader. So that is how I'm naming these right now. So just keep that in mind. Oh, I need one more parenthesis there to close up the set float. And with that, now that we have all of these things set, what we can do is we can apply the shader to the image. And we do this with another specialized method called graphics.blit. And this takes in we're going to use, let's see here, there's a few, this is the one. It takes in a source texture, which is going to be our source render texture, that initial camera view, and then it's going to apply that material that we created that uses our black hole shader, and then it's going to return that and say, here's your new modified image, put this up on the screen instead of what the camera showed. So we'll say source, and we'll apply material. Actually, there might be one more thing in there that I need. Let me double check here again. Let me delete these. Source. Ah, yes, because we also want the destination. Sorry. Should have gone one more further. We want both the source and the destination because we need this to tell where it's being passed to. So source, destination, and material. And with that, we have our black hole effect class done. We can jump back over to Unity. We have a I'm not sure that I'm going to delete this virtual. That was in the original script that I was borrowing from. I'm not sure that we're going to need it for this particular purpose. So there we go. That should solve that. All right. That was the only error we had. We can save our scene quickly, which we haven't done yet. So I'm going to call this black hole effect. And now in our project, in our hierarchy, we can go to the main camera. We can add a component. We're going to look up black hole effect. And now you see here we have these different variables that we're calling for. We don't have our shader yet, so we can't add that. However, we do have our black hole transform. That's this positioner here. So I'm going to click and drag that into the black hole variable. Our ratio will, like I say, automatically populate. However, for what it's worth, 16:9 ratio is actually going to be equal to 0.5625. So if you're using kind of standard widescreen format, that's the number that you want in there. And that's mostly important if you are trying to view the black hole in edit mode and it's not automatically figuring out that ratio for you. but I'm just going to put that in there. And lastly, for our radius, I'm just going to make this a size 0.25 for now. So it's going to be roughly half a unit wide total black hole. We can obviously adjust that as we need to. But with that in place, all the thing that's left to do is to put the shader into play. So we're going to have to create that in part 3. Part 3, making the shader. So now that we have our black hole image effect ready to go, we can create the shader that will apply here in this variable. Now, shaders are a little bit of a different beast to work with, particularly in monodevelop, because there is no autocomplete. And what that basically means is that you kind of have no idea if you're doing anything right until you go back to Unity and start getting errors. So if I can give you one huge piece of advice when creating a shader, it's don't create them from scratch. Definitely use the kind of default templates that they give you, that Unity gives you, and kind of modify them from there. So what we're going to do is we're going to right-click inside of our assets folder and create, go down to shader, and we're going to create an image effect shader. We're going to name this black hole shader. And then we'll open this up in monodevelop. First thing I'm going to do, I'm going to change this from a hidden up here. I'm going to put this in a folder that we're going to call custom, and this will kind of automatically create this hierarchy for you. But I want to be able to actually access this shader and actually, know what? No, we're not going to do that. I lied. We're going to keep that hidden because we're going to pull this from the assets folder and never actually need to access it from within a material because we're using our procedurally created material. So we'll just simply save that as is. Now we're going to keep this properties main texture here because what this really represents is the camera passing its screen view to the shader. So that's going to stay there. Though we're not going to be using it manually like you would normally in properties. And we're not going to add any of the other properties in here either because we're going to do all of that in our actual shader pass. The next thing we are going to add though is down here in our C program, we're going to add a couple more, one more pragma line, which is going to be pragma fragment option capital ARB underscore precision underscore hint underscore fastest. The next thing we're going to do is we're going to get rid of this struct v2f, this v2f vert, and this frag method right here. These were all kind of the base methods that Unity pre-populates, but we don't really need those. We're going to kind of go about this a slightly different way, so we can remove those for right now. What we do need, however, is we need to populate our properties. As I said up here, we're only keeping this one main text property up here that the camera can pass. However, because these are all being passed from a script we are creating instead of being put in manually, we have to add this uniform keyword into them all. So we're going to have uniform sampler 2D main text. Then we're going to have a uniform float 2 called position, a uniform float called rad, a uniform float called ratio, and a uniform float called distance. And you'll notice that all of these names line up with these variables that we were setting in our image effect, and that's why we need to make sure that those all match, because this is actually where it's now going to look and say, oh, I see something with that name matching the string in the shader, I can put that information here. And basically, to give you a quick rundown if you're not familiar, a sampler 2D is basically a texture. It's a two-dimensional thing that it can sample pixels from. A float 2 is a vector 2, because it's two floats, like an X and Y. And then floats are floats. So the language in shaders is a little bit different, but once you kind of work with it a little bit, you kind of start to see some similarities. They're just kind of a little bit different syntax, which is always, it's very much just like a different dialect, still kind of the same idea though in terms of coding. With those in place, we can now actually create our information we want. We can actually get rid of this app data as well. We don't need that. We're going to create our own struct for this, I think. Yes, we're going to create our own struct for this. So we can delete that as well. Now down here, I'm going to say struct v2f. And this struct is going to have a float 4, which is a vector 4, basically. POS position. And this is kind of a special keyword that basically states getting the position of something. Likewise, we're going to have a float 2 UV, which is going to be text coord 0, which means it's basically getting the texture coordinates of your first UV map. And now the reason we were able to delete app data is because we're going to use a special type of app data in our next method here. And this is going to return a v2f. We're going to call this vert, and it's going to take in an app data image called v. So instead of using that app data struct that we had before, we're actually, whoops, not app date, app data. And this will just kind of automatically pull an image for us. And so in here, we're going to establish, because like we see here, we're going to be returning one of these structs. We're going to return a v2f, so we need to kind of establish that there's a v2f here to work with. So we'll have a v2f, we'll call it O, and O's position is going to be equal to a function that we're going to call mul unity underscore matrix underscore MVP, and then v.vertex. So basically what this is doing is kind of pulling both the world position as well as the screen position. And then our O.uv is going to be equal to the v text coordinate. And then we can simply return O. So that just kind of gets us a quote-unquote vertex and converts it to a fragment, which is basically if your screen is a bunch of pixels and there's like a clump of pixels that are all doing the same thing, that becomes a fragment of your screen. For example, this little dot here is all orange pixels, so that might be one fragment. So it basically kind of groups things together so that your graphics, your renderer doesn't have to do quite so much work. You can kind of go, oh, I'm going to do the same thing for all of these rather than having to look at every single pixel individually. Lastly, we're going to have a method that's going to return a fixed 4, which is basically another type of vector 4. However, this is the one that's specifically used for colors. And so this is going to be our frag method, which is working with these fragments now. It's going to have the v2f passed into it. We'll call that I. And we're going to add the fact that this is basically returning what is specifically a color for us. Now in here, this is where basically all the math of the weird warping of the black hole happens. So the first thing we're going to do is we're going to put in a float 2 called offset. And this is simply going to look at the current pixels position that we're looking at minus the position, that is, remember, the position of the black hole. So it's checking how far away am I from the black hole. Next, we're going to have a float 2 called ratio, which is going to be basically the ratio we created and 1. And notice that this is kind of the syntax that they use for creating a float 2. Instead of saying like new vector 2 parenthesis and putting the x and y, you just, whoops, not ration. You just put brackets almost like you were creating an array, and that creates your float 2 for you. So that sets our ratio that we're going to work with. Next, we're going to have a float radius, a rad, that's going to equal length of that offset we created divided by the ratio. Finally, float deformation, and this is really the big, this is basically, I'll put up the equation here on the screen so you can see it, but this is basically the equation of how the gravity of a black hole is affecting the path of light. It's kind of frightening to look at, but basically we can convert this into code speak for us, and we're going to basically say 1 divided by POW, the radius, times another POW of distance. Basically, we're saying distance to the 0.5, and then we're saying all of this squared. We're going to multiply all that by our radius parameter and by 0.1. And so that whole thing right there is the deformation of the light path. With all that, we can now work with our offset again and kind of say now we know how far we were from the black hole, but now how far does this light need to look like it is if it's being bent so it looks like it's closer or further away or out of whack. So we're going to adjust our offset and say the offset is now equal to the offset times 1 minus the deformation. And then offset plus equals the position. So now we're kind of repositioning it back to relative to the black hole again. We're going to create a half 4 called RES. And this is basically the kind of the resolved pixel of what it's ultimately going to be. Text 2D, main text. So now we're taking that original image that the camera created, getting the particular pixel that we're looking for right now, but then we're actually going to get that offset. So we're saying, you know, oh, we would normally be looking at pixel, you know, the pixel at position 255, 334, but now because of this offset, instead what we're going to put there is the pixel at 300 and 700, and we're going to kind of drag it over, which creates this really warpy effect. Lastly, we're going to do a quick check at the end here and say if RAD, if the radius times the distance is less than our established radius, then RES should be set equal to, and in here we're going to actually create our own custom half 4, and much in the way that we just put in here 2 values separated by commas, we're going to put in a half 4 of 0, 0, 0, and 1, which is 0 on red, 0 on green, 0 on blue, and 1 in the alpha, so basically a solid black color. So basically, if this pixel, after all of this, is within the event horizon, within the surface of the black hole itself, just make it black. And then finally, after all that, we will return that resolved pixel. So, with all of this information in hand, we can now go back to Unity. Let's see here. And as expected, we do have an error. Unexpected token UV at line 29. Let's double check that. Float 2 UV, text chord. Why does... Oh, because I didn't use a semicolon in the line before. There, that should resolve that. Redefinition of V2F at line 32. And we're back, and I am proud to announce that once again it was me forgetting a semicolon that caused the issue. When you create a struct, you have to actually end that with a semicolon, kind of almost as if you were setting a array in a class in C#. It's not like it's not a normal, it's not a method call. You're actually kind of setting a new class or variable in your script, so you need to end that with a semicolon. So that is why that was causing that issue. Let's jump back and see if there's any more. Oh, now we have a syntax error. Okay, unexpected token at line 50. Oh, because we need to put a semicolon there, and that should be it because this is an if check, so that doesn't have a semicolon, but this line here, really, we should be doing this to look a little bit more appropriate. We probably would have caught that had I done it this way, so we'll save that there. Okay, so I was mistaken. I can't actually set a half for in the same way that I did the ratio up here. I think possibly because it's already been established as something. Instead, what I have to do is I do have to kind of create a new half for in this case. So we'll say half for parenthesis and then a parenthesis at the end here. So this will create the half for us instead of using the brackets. Save there. Now one more time we'll go back to Unity and we are free of issues. So let's jump over to our camera, to our black hole effect. We can now apply this shader to our image effect script. So now when we create the material, it's using that black hole shader. And now when we hit play, we should have a black hole that appears here. We won't see it in the scene, but we will see it in our game view. I'll turn off maximize on play for now, and let's hit play and see what happens. And there it is. It is floating in the scene. We can kind of move left and right and see that that black hole moves. We can also move the camera and kind of see that it moves along as well. And we see those really start to bend and warp in there. We can move forward and see that. However, there is, I think, as I'm looking at this and moving forward, because the camera is actually up here and the black hole is down here, there is something a little bit weird going on, and I think we'll specifically see it if I take this y-axis and move it up. Yeah, you see that the black hole is moving down. And the reason for that is that when I first was working with this, I was actually using, I was doing it with the VR headset, which is a really cool effect, by the way. If you have the opportunity to run this type of a program with a VR headset, it looks really cool to kind of walk around and see everything warping around. However, headsets versus screens actually use a little bit different math on how they do their y-axis. This is a really easy fix, though. We're just going to jump back over to our black hole effect script, and what we need to say here is, instead of just saying WTSP cam height, we need to actually say 1 minus this, so that it becomes kind of the inverted value. And that now, when we go back over to Unity and hit play again, now what we'll see is that black hole appears where it should have been in the first place, and when we move it, it moves up and down as we would expect and not in reverse. But bear in mind, again, if this were in VR, you would want that that 1 minus not to be in there. Otherwise, you're going to have the exact opposite problem. So with that, that really wraps up this video here. I'm just going to kind of move this around a little again so that you can kind of really see how that bends there. You can even take like one of these spheres and kind of move it behind. This is where you actually see it starts to bend around the black hole there too. So this is, like I say, a very Right now it's very kind of specific to a black hole in space, but you could use these sort of deformations to have some cool effects in really any scene you wanted, or you could put a black hole in places you wouldn't expect. So feel free to use this, and I hope you enjoy it. Thanks so much for watching, and I'll see you next time.